Good morning, all of you. So, in today's class, we will learn glass slab, refraction through glass slab. Okay, let's see. Refraction through a parallel glass slab. Refraction through a parallel glass slab. So, let me draw first diagram. Now, assume that this is a glass slab. Okay, this one is a glass slab. And now, object is here. This one is object. And this distance is what? X. One is slab and this side is air, and you are watching from this side. Like this. From this side you are watching. Now this is air, so here refractive index mu is equal to what? 1. And this is slab, so here refractive index for this glass slab is mu2 is equal to what? Let us suppose mu. I am denoting this with a dotted line. Okay. And let us suppose the thickness of this glass slab is T. Thickness of this glass slab is T. Okay. Now, object is here and you are looking from this side. Same like yesterday, you will get shift here. This shift, yes, in this case is equal to x plus T by mu minus x plus T. And that is equal to T into 1 minus 1 by mu. So in this case, you are getting shift is equal to T into 1 minus 1 by mu. That is the refractive index for glass slab. Okay, understand? Yesterday we have learned no D into 1 minus 1 by n relative formula. Same thing this also. Okay, got it. Same like yesterday. Whatever we have learned apparent shift formula, same thing here. This is for glass slab. Next one. Let's see now lateral displacement. Of emergent beam lateral displacement of emergent beam through glass slab. Lateral displacement of emergent beam through glass slab. So let's take again a glass slab. Okay, this is a glass slab. And now I'm incidenting a ray of light on it like this. This one is normal. Then after refraction, this ray bends towards the normal. This ray is bending towards the normal, whereas its actual path is like this. Where its actual path is like this. This I am denoting with dotted line. One minute, I will draw the diagram again because it is very small. Little big we will make. Okay. So these are the normals. This is actual path of the ray. But because of refraction, this ray bends like this. From this point to this point, whatever perpendicular we are drawing, this is your D. What is this? D. Lateral displacement. Okay. What is this? The lateral displacement. So let's give some names. So this is N1. This point is M. This point is P. This point is O. This is N2. Okay. And this is N2 dash. So here this angle is what? Angle of emergence. This angle is what? R dash. What is this angle? R dash. This angle is R. This angle is I, and this angle is what? I minus R. This angle is what? I minus R. And this point is point Q. This point is what? Point Q. And this ray is going here. That is point B. This is E, F, G, H. And the thickness of this glass slab is T. How much is the thickness of this glass slab? T. Now this is what? Air. So this medium is air, whose refractive index is mu A, and this is equal to 1. And this medium is what? Glass medium, and whose refractive index is what? Mu G. Okay, right? Understood? So this is a ray, first ray. We have incident on this glass slab, then it will refract, and then it again after second refraction, it goes parallel to the incident original beam. And this PQ is what? Your lateral displacement. PQ is what? Lateral displacement. So let's start now. So see, at point O, total geometry, this part, you have to just see the diagram and do it very easy. At point O, can I write like this? Mu A sine of I is equal to mu G sine of R. This refractive index into this angle, this refractive index into sine of this angle. And at point P, and at point P, mu G sine of R dash is equal to mu A sine of E. Okay. So let us suppose this is your equation number 1 and this is your equation number 2. Now, if R dash is equal to R and mu A is equal to 1, then what we will get from these two? Substitute R dash is equal to R and mu A is equal to 1, then we will get sine I is equal to sine E. Sine I is equal to sine E. Or you can write directly I is equal to E, angle of emergence. If you will see in the diagram, you will understand easily. Now, what we want, this PQ we want. So see here what I am doing. So now, lateral displacement D is equal to PQ. Lateral displacement D is equal to PQ. Now in triangle OPQ, which triangle? OPQ, sine of I minus R, sine of I minus R, you can see here I minus R is equal to what? This by this. What you are getting? PQ by OP, PQ by OP, and therefore PQ is equal to, see, PQ is equal to what you are getting? OP sine of I minus R. Okay, what I got? PQ is equal to OP sine of I minus R. Okay, up to this finished, right? Understood. Next. Now I am taking another triangle OMP. Which triangle? OMP. This triangle. You can see this is right angle triangle again. OMP. So again from triangle OMP, cos of R is equal to what you are getting? OP by OM. OM by OP, है ना? OM by OP, because this is adjacent side OM. So here you are getting OM by OP, है ना? OM is adjacent side, not OP. OP is what? Hypotenuse. So OM by OP. And OM is what? You see, OM means thickness of this. So therefore, shall I write like this? Cos R is equal to what? Or that implies I am writing like this. OP is equal to OM divided by cos R. Just I have transferred this and I got this. And therefore, PQ is equal to D I will write this side. Okay. So therefore, PQ is equal to, just at the place of OP, I am substituting this OM by cos R into sine of I minus R. And now PQ is what? D. PQ is what? D. OM is what? T. है ना? You know, PQ is equal to what? D. And OM is equal to T. So therefore, D, that is lateral displacement, D is equal to T into sine of I minus R divided by cos R. This is what your lateral displacement formula. Okay, what is this? Lateral displacement formula. T into sine I minus R by cos R. You can do it yourself, this geometry, it will be easily understandable. Okay, note down this properly. Try to understand. If you are doubt, call me. Okay, finished. Next. Now note point. If I is very small, R is also very small. Comma R is also very small. Then for small angles, sin I is nearly or tends to I, and sin R is becomes R, and cos R is equal to 1. So sin of I divided by sin R is equal to mu, which will become sin I will become I. So therefore, this formula is going to be like this: I by R is equal to mu. I by R is equal to mu. And therefore, you see now D, that is lateral displacement, what it is becoming? T into sin I minus R will become only I minus R. So this is just I minus R divided by cos R will become 1, right? So your D formula is just T into I minus R. What is that? T into I minus R, right? And if suppose we have divided this with I, that is D is equal to T, and I have taken common from this, then what is left here? 1 minus R by I. Yes or not? If I am taking I common, T into I means here what should be there? I by I, because we have to divide no inside, multiply and divide, we can say. So then this will become 1 minus, this is R by I left here, okay, because I already one we have taken out. So this is what we are getting, and R by I is what you know, this is I by R is mu, so R by I is 1 by mu. So D is equal to Ti into 1 minus 1 by mu, okay. And therefore you can write this D is equal to 1 minus 1 by mu into T into I. This is also one formula for lateral displacement if I and R are very, very small. Got it? Okay, next. Now refraction through composite slab means number of parallel media we have placed. Refraction through a composite slab. Composite slab means different slabs which we have placed one after another. Refraction through a composite slab, that is in bracket number of parallel media. We have placed number of parallel media. So first one, let me draw the diagram first. Suppose like this slabs we are having. This is first slab. Then shall I use colors? Wait, I will use colors. So this one is first slab. This one is second slab, whose thickness is little more, okay? And let us suppose this one is third slab, like this, composite slab, whose thickness is little more as compared to this, and so on. So many are there, okay? Right? So many are there. So here now you see this one is suppose having refractive index N1. What is this refractive index? N1. This is having refractive index N2. This one is N3. And this one is, let us suppose, N0. And here is what? Observer. Who is here? Observer. And here suppose somewhere we have kept object. This is what? Object. Here it is object. This one. Now this slab is having thickness T1, T2 and T3 respectively. For this it is T1, this one is having T2 and this one is having T3. Okay. Then if such type of things are there, then point number 1, that is what they are asking for you. That is suppose apparent depth. They have asked what? Apparent depth in this type of cases. Then apparent depth means what? Distance of final image from final surface. Apparent depth is what? Distance of final image from final surface. So in this case, you have to use this formula, that is T1 by N1 relative plus T2 by N2 relative plus so on plus up to Tn by N relative. Okay, you know this relative refractive index. You will use this formula. And next one, you will ask me what is N1 relative. Okay, so N1 relative is equal to N1 by N0. Keep it in mind this. N2 relative is equal to N2 by N0 and so on. Okay, this you will understand when you are going to solve problems. And one more, that is apparent shift. Now if you want to find apparent shift, same formula, just okay, same formula. This is also what we did, T by N relative, है ना? For nearly for that same thing you have to use here also. Apparent shift, that is T1 into 1 minus 1 by N relative, है ना? N1 relative we can say, N1 relative plus T2 into 1 minus 1 by N2 relative plus so on plus up to Tn into 1 minus N by n of n relative. How many number are there? Till 1, 2, whatever it is. Okay. So 1 minus 1 by n of n relative. Here we'll get 1 only, right? 1 minute. Here it should be 1 only. So these type of formulas we have to use for when you are solving the problems of composite slab. They will ask apparent depth, or if they are asking apparent shift. Got it? Right? So let's stop here for today. Please revise this. Okay, bye.